Hello everyone. Today I am going to discuss symmetry, which is an very important for our O-level maths exam. There are two types of there are two types of symmetry in our O-level exam. One is line symmetry and there is rotational symmetry. Line symmetry is what? A line of symmetry is the line that divides a shape or an object into two equal parts. That means if I divide something like this one, this is a rectangle. If I divide it here, that means if I fold it, I'll get same shape in both sides, this one and that one. If I fold it like that way, then I got two parts, both are same. So I can call it has two line of symmetry. It has two line of symmetry. If I show another one, this is square shape, right? If I fold it here, I'll get two parts, two equal parts. If I fold like that way, I'll get two parts again, right? If I fold like diagonally, here it divides equally two parts, right? And one surface overlaps the other, right? And if I fold it like that way, so how many line of symmetry here? One is this one, another is that one, and another is that one and that one. So how many? There are four line of symmetry. There are four line of symmetry, but in the rectangle there are only two line of symmetry, because if I fold it diagonally, it does not overlap. Like this shape and this shape doesn't match. These two shape do not match. Got it? Okay. This is what? This is parallelogram. If I fold it, does it match? This corner doesn't match this corner, right? Here also. So it is not line of symmetry. Again, if I fold it like that, it does not fold. It does not match. It does not match, right? So it is not line of symmetry. If I fold it diagonally, doesn't match. If I fold like that way, and the diagonals does not match. So I can say it has no line of symmetry. It has no line of symmetry. Okay. If I take rhombus, this is rhombus. If I fold it like that way, does not match. If I fold it like that way, does not match. But if I fold it diagonally, then it will match exactly. So it is one of line of symmetry. Okay, if I fold it in another diagonal, I will see that it will be perfectly fit. Is it fit? Overlaps perfectly. So I can say it has two line of symmetry. One is this one and another is this one. Two line of symmetry. So rectangle has how many line of symmetry? Two line of symmetry. Parallelogram has how many? It has no line of symmetry. Square has how many? It has four line of symmetry. And rhombus has how many? It has two line of symmetry. Okay, and trapezium, it has no line of symmetry. Okay, because I know that that was rectangle, so it has two line of symmetry because I can fold it diagonally and diagonal. I can fold it like that way and that way. For a square, I can fold it how many? 1, 2, 3, and 4. Okay, that's why it has four line of symmetry. Rhombus, it has two line of symmetry because I can fold it like that way and that way. So it has two line of symmetry. And parallelogram has no line of symmetry because I can't fold it. If I fold it, it will not be fit. It will not fit. Okay. Now I will discuss a question from past paper. In number 6b, it is the question of 4024 12 variant October November 18. Question number 8, marks 2. It has 2 marks. Okay, so in number B, this says in the diagram 6 small squares are shaded. Here 6 squares are shaded. 1, 2, 3, 4, 5, 6. Shade one more small square to give a diagram that has exactly one line of symmetry. So we have to shade one more square from here. Okay, so if I observe here, this one shaded, and this one shaded. If I shade here, if I draw a line of symmetry here, then here is one and another is here. Okay, so so half part is here and another half part is here. If I shade this one, then both parts, I mean both sides will be similar here. Both sides will be same here. So I can say if I shade this square, then there will be exactly one line of symmetry. This is the line of symmetry. If I shade this one, then it will be the line of symmetry. Okay, so I have to shade this one. Another question, In the diagram, the three small triangles are shaded. This is from 4024, 11, October, November, 19. Question number 15, marks 3. In the diagram, three small triangles are shaded. 1, 2, 3. 3 are shaded. Shade one more small triangles to give a diagram that has exactly one line of symmetry. So I have to shade one more here, right? So if I shade it here and then it will be the line of symmetry, right? If I fold it, then this will replace this one, right? This will replace here. So I can say if I shade this one, this figure will be this figure has one line of symmetry. Okay. This 8 number. The diagram shows a circle, its center and two chords of equal length. This is a circle and these two are equal chords. Equal. Okay, equal chords. So the diagram has one line of symmetry. It has one line of symmetry. Draw this line of symmetry. So if I draw a line here, you have to draw it with a scale, okay? If I draw a line here, then this part and this part will be like same shape, right? If I fold it, it will match perfectly. It will fit. This line will fit here. If I fold it here, this line will fit here. So I can say this is the line of symmetry. Now come to the rotational symmetry. Rotational symmetry is what? A type of symmetry in which it looks like the same after some rotation by a partial turn. If I rotate something and then if I get same shape, then I can say rotational symmetry, like this one. So this is a rectangle, we know that. This is a rectangle. If I rotate this one, I will get the same result, isn't it? I will get the same shape. So I can say it has rotational symmetry of order 2. Rotational symmetry of order 2. Now for parallelogram, if I rotate this one like that, then I will get the same result, isn't it? So I can say, what is the order of this one? Order 2. Rotational symmetry of order 2. If I take a square, if I rotate this one 4 times, then I will get the same shape, right? Like this one, this one, this one, and that one. For the 4 times, I'm getting the same shape. So I can say order 4. Rotational symmetry of order 4. And for rhombus, I will get 2 times the same shape. This one, observe the figure, this one, and that one, the same, 2. Someone think that it has 4 rotational symmetry, but no, it's wrong. Observe here, this angle is acute angle, right? This corner has an acute angle, right? If I rotate this, is it acute angle? this angle is more than 90, so it is not acute angle. So this shape and that one is not same, different. So it has no order of rotational symmetry is 0, no rotational symmetry it has. Okay, now I'm solving some problems from past paper, like this one. They said in the diagram below, two small triangles are shaded. These two are shaded. Shade one more small triangles to give a diagram that has rotational symmetry of order 3. In that case, look the figure perfectly. In the lower line, it has a shade. Second number of the left, right? 1, 2. This one is also same, right? And rotate again. So that one is the same, isn't it? Now if you look this figure from 3 sides, you'll get the same figure, like this shape, same, this you'll get the same, and this you'll get the same. Okay. They say the diagram shows part of the figure that has rotational symmetry of order 4 about the point O. Complete the figure, you have to complete it. So rotational symmetry of order 4, that means if you rotate 4 times this figure, you'll get the same shape. So I can draw it like that. Then if you rotate it, this, you'll get the same shape. You will get the same shape, and you will get the same shape. Okay. Now I'm showing another one. The diagram shows part of a shape which has rotational symmetry of order 2 about the origin. This is origin and rotational symmetry of order 2. Complete the shape. At that case, I follow a technique, that is, first of all, observe this figure perfectly. Observe this point. Observe every point, but at first observe this point. Look at here. This point is where? From left side, if I count 1, 2, 3, third number column, and if I, and here there are 2, right? 1, 2, 3, 1, 2. So remember that 3, 2, 3, 2. Okay. Now as it is order 2, now rotate it 180 degree. Exactly the opposite figure you will get. Then remember that you got 3, 2. That means 1, 2, 3, 1, 2. So this will be the image point of this. Now do the same thing for another one. Now this one is where? 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5, 3, 5. So then rotate again 180 degree. 1, 2, 3, 1, 2, 3, 4 5. So it is the point. Now take the original shape again. Now I am taking this point 1 2 3 4 1 2. So it is what 4 2 4 2. Now rotate again 1 2 3 4 1 2. So this is the point. Now again, now I'm taking this point 1 2 3 4 5 1 2 3 4 5. So it is 1 2 3 4 5 1 2 3 4 5. 1 2 3 4 5 1 2 3 4 5. Sorry, 1 2 3 4 5. This one. So then draw this, connect these points. Then you will get the same figure, same shape for the given one. Then you can say it has rotational symmetry of order what? 2. If it has rotational symmetry of order 2. Now come to this point. It is also symmetry of order 2. So do the same thing again. At first take this point 1 2 3 1 2 3 1 2 3 1 2 3. So this point is already given. So for this point, image point and object point is same because it is center. Now take this one. From the right side it is 1, right? 1 from the right side. If you want, you can take from left side also, then it will be 1 2 3 4 5. But for easier, I can take from here, right side 1 1 2 3 4 1 4. Okay, 1 1 2 3 4. And another is here from the right side 1 1 2 3 4 5. I'm getting this one. Okay, I'm counting again 1 1 2 3 4 5 1 1 2 3 4 5. So this one. Now connect these points. You get the result. So it has rotational symmetry of order 2. Line number, from the above, write down all letters which have line symmetry. So if I draw a line here, it will be divided equally, right? So I can say H has line of symmetry. If I draw a line here, it will overlap. So A has also line of symmetry. If I draw a line here, it will not be overlap. This will connect here, so it is not overlap. If I draw here, it is not overlap. This has also no line of symmetry. But for that one, if I draw a line here and fold it, then this will fit here and it will be exactly fitted. So at that case, I can say E has line of symmetry. Now for the rotational symmetry, I can say H has also rotational symmetry, because if I rotate it, I will get the same shape. For H has rotational symmetry, and N has and has also rotational symmetry, because if you rotate it you will get the same shape. Okay, you can see like that way, and has the same shape. So n has rotational symmetry. So I can say R has no rotational symmetry. This is the answer. Write down the order of rotational symmetry of this shape. How many rotational symmetry of this shape? If I rotate 3 times this one, I will get the same shape, same result. So answer is 3. Okay. Symmetry describes a special quadrilateral. It has only one line of symmetry. Its diagonals cross the right angles. Okay. So write down the name of the special quadrilateral. So if I draw a kite, we know that kite has adjacent equal sides. So this side is equals to this side for the kites. For any kites, we know that adjacent sides are equal for the kites. So if I fold it like that way, I'll get line of symmetry, similar shape here. But if I fold it like this way, I'll not get the, because it will not overlap here. Okay, so I can say it has one line of symmetry. So the answer will be kite. So for today, I'm finishing now. I hope it will be very beneficial for you, and I hope you'll get some tips from here how to find the rotational symmetry of order 3, order 2, or order 4. Okay, and I hope it will be useful for you. If you face any problem, you can comment me here. Thank you so much.